Well, good morning, everybody. We will get started here since it is 5 minutes past the hour. I guess nothing really changes. Whether we're face-to-face or virtual. People are late. Okay, good morning.
Good morning, Tom.
Good morning, Ahmed.
How you been?
Doing well, doing well. You know, I miss seeing everybody, but this is not too bad. With the Zoom, it seems to work out pretty well each week.
Yeah. Um, most of us missed last week, so
I know. There are videos. I sent links.
I didn't check it because I didn't have any access to the inventor, to be honest with you.
Okay.
And my roommate, he took his device with him. He had a lot of labs to do because he's doing cybersecurity, so he's working with Linux all of the time.
No. And the new option is that you can start in on Fusion and use the Fusion software instead of Inventor.
Does it work on MacBook?
Mm-hmm. Absolutely.
I didn't know that, to be honest with you.
Yeah, so you can install the Fusion 360. We'll be doing a little Fusion work this morning. And then we'll talk. I just sent out an email to everybody.
To turn
And
on the Arbor Press and
yeah, so ArborPress and the video links should be turned in at this point. I haven't graded. I graded all the other classes, but I've been holding off on this class on grading until probably today. I'll probably work on that this afternoon on grading.
I didn't turn it on for you yet because I missed the. There is a part for the Supergear. It's not the Supergear. I left my part on my desktop on Sinclair, and I can't go to Sinclair. Uh, let me tell you which one I have lost.
Okay. I thought I emailed that part to everybody through the eLearn system, which means that it's still in your eLearn.
Still in my ear.
Yeah, because I emailed that part to everyone. So that way you've got it inside your eLearn environment. So yeah, so you're looking at right now what I'm sharing is our class. And week 10 has us turning in our ArborPress animation. That was 2 weeks ago. Week 11 has finite element analysis, which is the diving board, which is what we talked about last week. So I wanted to see if there's any questions with that.
Do you have video on the diving board?
Yeah, we actually do have video that I believe I sent everybody from last week's presentation. It's a private video of this class. And so that particular video goes over how to put stress analysis both in Fusion and in Inventor.
Mm-hmm.
And so the diving board problem is a stress analysis problem to figure out how far the diving board displaces when a 235-pound object is placed on the end of the diving board. So that's kind of an interesting project. However, I can guarantee that everybody will get it wrong, which is okay because everybody places the force in a different location, and so that will impact the actual answer. So you get it wrong, you turn it in, I have to manually grade it, and then everything works out okay because you're usually within the tolerance zone that I accept. The week 12, which is where we're at this week, and week 13, we're kind of like right in the week 13 timeline. When I looked and counted this morning on the number of weeks, we're right at week 13 here. 13, 14, 15. Yeah, so we're right at week 12, week 13. So week 12, here's the best part about it, is that you've got no assignments on week 12. And I figured I'd get at least a thumbs up or something in the text message for that one. Yeah, so there's no assignments in week 12 that you need to worry about. Because if you've turned in the animation, then realistically you've rendered the software. Now we could talk about how to do more accurate rendering today, which is one option, and I'd be happy to do that in Inventor and Fusion. But I was really looking at week 13 as where we're going with the project, and then week 14. And start to introduce week 13 and week 14 to you. And so that way you've got an extra week to start in on your candy dispensers. And to get that done before the end of April. Okay, it sounds like we're going to be meeting virtually here through the end of the class, which we expected overall. And we'll continue to meet on our 8:30 to 11 a.m. basis on Monday and Wednesdays. And then Tuesday night, I've got the help session, which is definitely helpful for you to join on Tuesday evenings and to get your Q&A done. Because and the reason why I wanted to start the candy dispenser early was you need to do a little bit of reverse engineering with it. And so what we're going to be covering in week 13 with reverse engineering applies to our candy dispenser project. So that's kind of a rundown. And then we've got week 14, 15, and then week 16, which is our finals week, which is the last week of April. So April 27th is our last week. That week, we turn in our candy dispenser. So we have to work backwards. So if April 27 or 29 at the very latest, because I expect all projects to be turned in by Wednesday the 29th, so I can get grading, my final grading accomplished. So Wednesday the 29th is our final day that we'll meet and get projects turned in.
All the projects, Tom?
Yeah.
Okay.
So if you haven't, you should be turning stuff in every week as it is. But yes, all the projects have to be turned in before Wednesday the 29th.
Yeah. I have, as I told you, my question now, where to get the Fusion 360 on my Mac?
So the same place that you got it before was students.autodesk.com. So you just go up to your Autodesk students.autodesk.com account, and then you can download the Fusion. You'll have to log in with the same login, but it will run because it's primarily a online tool, and I know for sure that they do have a Mac version of that. So looking at the calendar, if we're working on the 29th, backing that up, it's going to take you 2 weeks to get your minimum of 2 weeks to get your candy dispenser together. And then that backs us up to roughly the 8th of April. And we're at the 30th of March. So we've got about 8 to 10 days to work on these other tasks that need to get done. So we'll introduce one step of the candy dispenser today on the reverse engineering. Along with that, as you can see, we've got 2 projects to work on week 13, which is the measurement tools and the micrometer reading. And what these are is that we have you read measurement scales. So we've got images of micrometers, and you have to read whatever the reading is on the micrometer. And if you're not sure how to read a micrometer, let's see here. I believe in learning resources. Nope, I don't.
I took the machine metal class last summer, so they taught me how to use all that stuff.
Well, cool. There are a lot of, I don't have anything specifically in here. I should probably throw a link in the learning resources area. But the measurement reading is pretty easy. You're just reading different scales. The micrometer reading is a little bit different. I don't know if it's going to pop up or not. It probably won't pop up in the screen because it's part of the quiz.
Easy.
And I guess I'll start the quiz and I'll give you a quick preview of it. But the micrometer reading basically shows you what the micrometer settings are, and then you've got to read the value based on those micrometer settings. So if you've never read a micrometer before, basically what you're doing is you're taking
The line, yep.
Yeah, you've got to take your major reading, then you've got your minor readings here. So let me find a good page online. You can always, have Mr. Google help us, and that's what I'm going to be doing here during break. Is I'll find a nice Google page to send you to, and have you look at the micrometer readings. All right, so let me go ahead and stop my share or do a new share of. Let's see here. We'll share in on Fusion. All right, so Fusion 360. And one of the things that I promised was that we were going to do a little bit more Fusion 360 work with our group here, because Fusion is the future software that you're going to be utilizing. And as a student of Sinclair, we learned last week that we've got some amazing opportunities with the Fusion tools. Let's see here. Last week, I think we did this load and nope, we did the plant hanger. So last week wow, I got all this stuff in the plant hanger. I got all the extra bonus stuff. But last week we worked on the plant hanger here, and we applied our forces. The design inside Fusion is pretty consistent with Inventor, and so that's kind of what I wanted to talk about today, is how to design parts and how to create drawings out of Fusion. Was going to be my major presentation today. Animation is the side component of the Fusion environment, and working with the animation components along with the assembly, that's different. Okay, that I will tell you is totally different than what you're familiar with in Inventor. All right, so quick review. Last week we designed the plant hanger. In the design tab, we went down to simulation, and then we ran the simulation of applying the forces on the end of the plant hanger. And we then looked at what the results were, the study results, and we determined that the information that was provided was the exact same or very close as the information that was provided in Inventor. And then from that location, we determined that we needed a brace and we discovered that when we put the brace closer to the end, or where the plant actually hangs, made an impact on how much bend we received or displacement of movement we received. So putting the brace back at about 50% did not impact it near as much as putting the brace out in the 75 to 80% range on that distance. The location or the height of the brace wasn't as critical as the location out to the outer edge. So inside the simulation tool, one of the interesting things as a Sinclair student, and as you downloaded and installed Fusion through your Sinclair or my.sinclair.edu login, one of the information components, or one of the cool things about being the Sinclair student, is that you have unlimited credits to run simulations. Let's see here. Let me do a quick.
I'm on Autodesk trying to download the Fusion 360.
Okay, well, good.
Yeah.
So, like for example, let's see here. Our results are out of date, and so if we were to run this again, we'd solve it. And simulation, why can't the study be solved? Let's repair it. Okay, close. So it says that we have a material that's out of date. Because these objects are still in the simulation. So I actually have to delete all these objects that are in here. And that is the issue, is that I put all these extra objects in and it wants to run the simulation with these objects in it. And we don't want that to occur. And so I am going to need to go back to the design, delete it out of the design, and then we can, and that came from our discussion. Go back to simulation. So if I now run the simulation again and solve it, it takes 5 cloud credits. Okay, so how much do you think the cloud credit costs?
Is it free?
Well, it is for you. So how much do you think a cloud credit costs?
99 cents.
99 cents.
That's for Apple stuff.
Everything's Apple stuff with 99 cents. Cloud credit. Any other guesses?
100 per 100 credits, or like
Well, how
dollars.
much? Yeah, how many dollars per credit? So if I were to go out and buy cloud credits, like this is going to cost 5 cloud credits. Well, how much is that in real dollars? Because a company has to physically spend the money to run this. They don't get that for free.
That's crazy.
You get it for free.
I would say maybe like 5, be like $1.25.
So it's $1 a credit. So for a company to run this analysis will be $5.
I was right.
So you were right. But we get unlimited crowd credits as students and faculty, because Autodesk wants us to encourage people to learn how to do these particular skill sets.
Is it like they have all these new video games out where you got to buy everything to play it? So is the program free and then you just buy stuff?
No, the program is not free at all. So the thing is the program you pay for, and then you pay for the different capabilities of skill sets. So like the simulation cloud credits are $1 a run. If we do generative design, I don't have any jobs set up for generative right now, but in generative design, that costs like 100 cloud credits to generate like 100 or 200 different model designs in generative. And if we get an opportunity towards the end of class, I'll demo a generative design capability. But yeah, so this costs $5 to run that animation or that simulation to get the results for the displacement of what we were looking for. And of course, they provide some recommendations on the safety factor. And so, quick note on safety factors. Safety factor. Whenever you design something, there's always a safety factor. Okay, there's always a safety factor. And so, like for example, if you've used the ladder, there's always a weight rating on the ladder. So it'll say, you know, this ladder is 200 pounds or 250 or 300 is the rating that they set on the ladder. But there's a safety factor associated with it, with that ladder itself. And people exceed that safety factor almost all the time.
Is it double, right? Double whatever the weight says.
It's actually triple on a ladder.
Huh.
But that's triple for the force. That isn't, so it may say 250, and that's static. That's if you were standing right in the middle and you didn't move and you didn't reach, it'd be 250. The minute you go up to, let's say, the second or third to the top rung or the top of the ladder, and you start to reach, that force that you're applying now multiplies. And so as you lean farther away or as you grab other objects and add additional weight, that actually adds a significant amount of stress to the legs of the ladder. And so you have to be very cognizant and you have to be very aware that you pick the right ladder. So using a 200-pound ladder and you're reaching, you know, 2 feet off to the right-hand side or to the left-hand side, on that side with those legs, you're applying a significantly higher force than you would if you were just standing straight up and down through the middle of the ladder. And people do that all the time, and then they wonder why the ladder breaks, because they've exceeded the safety factor of the ladder. And so I actually did there was a session at one of the conferences I went to on safety factors of ladders. It was the ladder manufacturer doing the safety factor, and they were showing all these pictures of how the ladder just buckles. And it's like, crud, I got to make sure that I'm using the right ladder. So don't undersize the ladder, because the amount of forces that you put in are dramatically higher than what you expect on the ladder. So that's your PSA announcement today on ladders. But the safety factor does matter. And so they would like to have a 3x. A safety factor of 3 is common. So it's 3 times the design analysis. And so right now we're at 1.56 before it fails. And we could actually put more force on this, and it would tell us that it would fail. It just wouldn't accomplish the actual analysis, and then we'd know that it would fail through that process, because it would just not run the analysis itself. All right, so that is cloud credits and the analysis. And if you remember, when we did the analysis, we locked down both the holes and the back surface. Okay, so we made sure that the back surface was static along with the holes, because as we mount this to the wall, nothing against the wall is going to move. So that is the process. And so if we choose displacement, load case 1, displacement in inches. So yeah, right now it's moving almost 3/4 of an inch without that bracket or support in there. It's pretty amazing how far this moves without that support bracket built in. So from this front edge, it moved down 3/4 of an inch. Wouldn't fail, but it would be darn close. All right. Any questions on that?
How do you want us to turn in the diving board?
When or how?
How? Like,
So there is a quiz, and so there's a quiz on that week. So in that week of, I think, week 11. So inside week 11, we had, let's exit this preview. Sorry, I'm getting back to my previous week here. Under content. So under week 11, there is a diving board quiz. Just click on the quiz. It'll ask you for your answer. You'll type in your answer. But it will be graded manually because it's going to show up as incorrect. Unless you exactly hit the number that I type in, it's going to show up as incorrect. But that's okay because I accept a tolerance range because as you remember, placing this force is not 100% accurate. Okay, where you pick along that edge will determine a variability in what the actual displacement distance is going to be. So I accept a range. The computer, however, doesn't allow that in quizzes. It wants one answer and one answer only, and that becomes a problem. So that's why I put the note on the quiz to say, hey, it's going to show up as wrong, but don't freak out.
so do we not turn in like a file of it or anything?
Nope, all I need is the answer.
And then is there like, do we just kind of come up with our own diving board?
No, under the diving board stress analysis assignment, let me go ahead and share the screen again. Screen 2. Oh, wow, you're going to see yourselves on screen 2 if I do that. I'll share that. Okay. So under the diving board assignment, which is again under week 11, talks about how diving boards are placed on pools. And then here's the diving board design itself. And it shows you your mounting holes for the diving board, the width, the length of the board, and it tells you that the board is 6 foot long, must overhang the pool by 2.33 feet. Support for the board is 11 inches back from the pool edge. Calculate the mounting hole positions, and it says that you're going to a person who weighs 235 pounds is on the end of the board. So you're going to design the board, figure out where the fixed locations are, and then the board will then place your force on it, and the board will provide a value.
As long as we do everything right, it'll be great.
Well, as long as you've designed the board correctly and placed the force correctly, and then when you run the analysis, it'll give you a value. And as long as that value is within the range that I accept, and I've got a pretty wide level of acceptability because there's 2 different ways to mount the board, and apply the constraints on the board. So I have to take that into account. So I just thought it was interesting to see how diving boards are placed. And by the way, if you've got a pool with a diving board, your insurance rates are dramatically higher. Having a pool with a diving board or a slide even increases the insurance rates for having
So do
that
we
pool.
put anything underneath the holes? Or anything like that?
Well, the holes are mounted, so we didn't draw the wall behind the hanger.
Yeah. Okay.
You know, if you think about it that way, we didn't draw the wall behind the hanger. And it tells you what the material is of the diving board. So yeah, the diving board project. It's actually pretty easy when you think about it overall. The key is getting the position of the holes correct. That's the key.
But you gave us all that information too, so
But I gave you all that information, so yes, it should work. All right, so let's talk a little bit about Fusion 360. And
no.
what do you mean no?
I'm just kidding.
What
I
do
just
you
wish we
mean
would have
no?
more time on it. You know what I mean?
Well, we haven't spent a whole lot of time on it, but you've spent a lot of time doing Inventor, and the design side of this, along with the drawings, are exactly like Inventor. The only difference between Fusion and Inventor is primarily in the assembly and using the assembly tools. And again, I'm not going to specify what software you have to use for the final project. You can use Fusion, you can use Inventor. Okay, either way, for that final project development. All right, let me go ahead and share Fusion 360. All right, so there's my Fusion 360 screen that pops up. And as always, if you have questions, you can always type them in the Zoom chat, or you can just blurt them out and we'll work from there. And if you want to follow along and you've got Fusion loaded, perfect. If you don't, that's okay too. But I was going to start from the beginning with Fusion, like how to create an actual drawing in Fusion. Good point. Let me bring up a drawing project in Fusion and see if we can draw it together. So while I'm doing that, give me another minute or two to grab a drawing. If you don't have Fusion installed, you should be able to install it within, I mean, it's pretty easy. And or if you don't
Does it
plan
take up
on
as
using
much space
Fusion,
as Inventor? Or should
nope,
I delete Inventor?
it's actually really small because most of it is run online. So it's a pretty small program ultimately.
So I'm still couldn't find where to download it. It's still just download the free trial, but I'm not gonna get the free trial.
Yeah, if you download the free trial, and then when, let's see here.
Because I'm at Autodesk.com trying to get the Fusion 360.
Did you send us a link to all that?
Can I send you a link? A link.
Get a free education license. I mean, trying to.
So there's the link. It's in chat. That'll get you to the education page. Then you've got to log in from there. And once you sign in, and you had to have an account. I'll even share what I'm doing here. New share, back to screen number 2. Boom. Okay, so I'm actually in Autodesk.com Education Home. I'm in the process of signing in. Okay. So when I sign in, I'm in the education side of Autodesk.
Autodesk.com.
Well, I put the link inside chat. It's autodesk.com/education.
Let me check the chat. Okay. Yeah, I'm on the same page now.
Okay, so once you're in this page, we're just going to go to free software. By the way, on this page, inside Autodesk like this, you can go under Learn and Teach, and there's a ton of videos and support. And if you have problems installing it, you can go under the support tab, look at the frequently asked questions, and there's also a community up here that has got a lot of support information. But all I did was pick free software, and under the free software, it says take a free online course designing quickly with 3D modeling, but Fusion 360 is here. And so you're going to be getting an individual license because you're not going to be doing a lab installation. So you'll be doing an individual license. So you get your individual license. And when I have an account, sign in. I've already got all this. So it'll then tell you, you have to complete your profile, and then it'll give you access to do that.
So we sign in right away, right?
Yeah, so Fusion is available for Mac and PC. It works on both.
Create an account.
So you got to log into the Fusion side again. Basically, it's the same login. And then I need an account. Nope, I've got the account. I can download the software. And when you download the software,
I log in through my Sinclair email, right?
well, whatever the login is that you got into the students.autodesk.com is the one that you use for that login. So getting the free software, you log into the same way you got into that Autodesk area. So when you're under Autodesk.com education, you signed in. That gave you access to this. You want to then log in and use that same login again to log into your.
No, it didn't work because I'm already in Autodesk education, but.
Okay, but you want to use the same login that you use to get into Autodesk education, not your not the my.sinclair one that you get into Sinclair with, but the so for example, I'll go back all the way out and I'll do it again as a demo. Let me go ahead and sign out. All right.
I'm on the link, the one you just sent in the chat box.
Yeah, so if you're on the link, okay, you go to sign in up at the top row. Then you go to, let's see here. I just go to the sign in on the bottom.
I honestly, I don't remember that how to create an account with this.
Well, you had to get Inventor. And if you didn't, then you'll then create a new account. And you want to use your my.sinclair.edu email address. So as you can see, my email is my email.
I did, but I don't know. I forgot what email I did, to be honest with you.
Well, you want to use so students want to use their my.sinclair.edu. Oops. Yeah, students will want to do this, my.sinclair.edu email address. So whatever your my.sinclair.edu email address is, that's what you want to use. That is not your eLearn email address, but your Sinclair account address. And so once you've logged in or created your account using your my.sinclair, it'll then obviously have you put in your password. If you forgot what your password was because you logged in and you forgot what it is, you can go ahead and reset it. But once you sign in, then you're able to download the software for free.
Okay, it's already exists, so it should be good.
Well, then you just have to,
Okay, I'm in now. I got my email. I got my
yeah, so
password
you're,
right.
okay. So now you're in on this page, and then you can
Mhm.
go to free software on the top row. And then you're going to go to Fusion 360, get it now, individual license.
Okay, and then get a free education license. Complete profile, get access.
So yeah, get access to Fusion 360, complete your education profile.
You gotta complete it.
And complete the profile, and it may have you log in again. Same login,
Yeah.
exactly the same.
And then get it started. It says protect your account. Get started.
And then it'll ask you to download the software. Yep. So you'll then download the file, you'll then download the software. And it automatically, if you take a look at the very bottom of my screen, it shows that my Fusion 360 client is now downloaded to install it. Then you can download this really cool car. That's the other advantage. It's a big car, 40 megs. Yikes. It is one large car. So yeah, you can download the basics. So once you have Fusion, the whole idea is that we're then able to create and build using the software, which last week we built the ARM. This week, let me go ahead and, as I suggested, I was going to find a model for us to work on. And I'll send you a model picture. Okay. Does everybody else have Fusion ready to roll?
It's setting up right now.
I don't have Fusion.
Okay.
It's easy. I just figured it out, Tom. Thank you so much for the guiding.
You're welcome. Yeah. Okay. So we are going to design a part this morning. Oh yeah, I love that part. Okay, so let's do that. Or would you prefer to do an assembly? What's your thought? Part or assembly?
Assembly.
We
Josh
didn't have
wants
to
to.
talk to that then.
Well,
I finally had a breakthrough yesterday.
you had a breakthrough yesterday. Okay.
I have been struggling. I think it's more due to stress than anything else. But I finally got my Arbor Press animated
Good.
with all the parts. The only thing I'm having a problem with is I can't get all the handles to stay put. Like I can do a couple of them, but the rest of them aren't wanting to stay put.
Yeah, you got to use the insert tool on
That's
the holes,
That's what I was
and
doing.
yeah, that's the only way to really get them to stay put is with the insert tool.
I think my problem is when I was making those parts, what you were seeing, I
Yeah.
did that on like all of them because I was trying to create too many planes, and so I started going through and deleting all this extra stuff that I didn't need, and I started getting everything to work. But I'm about messing with it right now. I just want to turn what I got in, and if I get a passing grade, I'll be happy.
I understand.
I don't want to take any more time doing it. But pretty much, I just didn't get the screws put in.
I can't remember. I got to figure out which auxiliary. I'm looking for my information. Hang on just a second here. Okay, I thought that was, so Appendix A is what I need to find. All right. All right, so what's going to happen is I'm going to end up probably emailing you.
Tom, here in the Fusion, when I download it, it says it's used my Sinclair email, and then it's asking to create a team or join existing team.
You can create your own team. That's fine. I could set up a class team, but I have not done that. So you just create your own team.
Mm-hmm.
And then you should be okay. Let's see here. I guess we could do.
I'm glad that you work on the MacBook.
Yeah, no, it's actually pretty sweet on how this works. All right, so that is going to require me to. All right, let me take a picture of this. And save it. I'll save it as a JPEG. All right.
Yeah, I got it.
Good. So here's what we're going to do. I can't send you files. Yeah. Anya wanted a part. Jason wanted assembly. I have a really good compromise between the two. And let me go ahead and let's do this. I think it should be here. Yep, it is. Okay, so that's there. And I'm going to have to, that shares that. I'm going to have to email that to everybody so that way they have a copy of it. So let me run up here and I'll do a quick email. It's a real simple, I'll show you what it is. It's actually a,
Hopefully I get it. My email didn't work all weekend. I logged back in this morning to go to Zoom through your email.
mhm.
I finally got the one you sent from the class last week, and I didn't get any of that till today. I don't know if it didn't log me out, so it didn't update, but I update it every day because I find out what's going on if anything's different from email.
Yes.
But it would have been a lot helpful if I would have had that earlier last week.
No, I understand. I'm with you.
It shows the date like the 24th. I was like, oh my gosh.
Yeah, the Zoom meeting each week is the same for our Monday, Wednesday class, but is different on the Tuesday, Thursday.
Right. No, I went to find the email for it, and all of a sudden all those other emails popped up.
Gotcha.
It wasn't just you. It was like some other people from school.
No, I understand. I'm with you. All right, let me do this. Let me reply to all. I need to attach the image to it. My computer. I gotta upload the image. I have so many windows open right now. You'd be impressed. We're gonna add that. And send. So I just sent through eLearn the picture, and I'll show you. I mean, I can flip up and back. It's let's see here. I don't think I can do two windows at once, so I'll have to do the share. But I can do this. I can share that. So this is what we're going to design today. And that design is going to be done in Fusion. And we're going to talk about how to create a basic assembly with the caster. It's a really simple project overall. And the idea is to we can design three parts. We've got the plate on the top. We've got the actual wheel mechanism, and we've got obviously there's a pin of some sort that has to hold the wheel in place. So there's three parts. So the plate, along with the attachment components, are located in the drawing, and then we've got a plastic roller. And so this one does not swivel. This is a tool that does not swivel. All right, so everybody on the same page here of what we're going to be creating?
Yeah.
So if you want to,
I'm still trying to get 360 up. Can I just do it in Inventor so I don't have to waste time?
you can. Again, the Fusion 360 is, you want to go back and do it in Fusion 360 when you're done to practice this. If you want to do it in Inventor, you can do it in Inventor. However, you'll want to go back and test it in Fusion 360 because that's ultimately our goal. For our final project, you'll get to choose whether you want to use Inventor or Fusion to do your final assembly with the candy dispenser. And so just as an FYI, the candy dispenser, you're going to need to find some candies to reverse engineer. So Typically, I bring candy in, and we have everybody reverse engineer the candy in class. However, that isn't going to take place. So you're going to need to find some candy or another small object like candy that you can dispense for your candy dispenser. So that's going to be another task that you're going to want to work on this week. Typically, things like M&Ms or Skittles, Reese's peanut butter cups, Twizzlers, we've used it all in class. And we've dispensed all of them in class. Typically, I provide 2 or 3 fairly easy ones like Jawbreakers and M&Ms. Those are really easy. But then I also give you one more difficult object like a Twizzler or a Reese's peanut butter cup or something that is out of the ordinary that you also need to dispense. And so we'll get more into that. But this week, if you can, and you haven't eaten all the candy up now that you've been self-quarantining and staying home for the last 2 weeks, try to search out some of that. Do not specifically go out to try to buy candy if you don't have any at home. I'm not if you don't have any at home, what we can do is share some dimensions of candy that others may have, or that I could dimension either way. But again, don't go out for a shopping trip just for candy. This is a situation that if you've got something like candy, or it could be anything, any small objects like candy that you can dispense through it would work. If you don't have candy, then what I would do is do a coin dispenser, quarter, nickel, penny, dime. And so you'll have to dispense those particular objects. And we'll get more into that. So we'll either do a coin dispenser or we'll do a candy dispenser depending upon who's got what available. All right. So in Fusion, and what we're going to do is we're going to take this Fusion design and we'll start a fresh design and work from there. So in Fusion, what the interesting component is, the interesting component about Fusion is that you can have multiple people working as a team on an assembly or on a project together. And so as Ahmed's indicated he needed to set up a team, well, that team, he can invite others to go and see the materials in that team itself. Over the last 10 days, I've invited friends working on a face shield design project that we've been working on, and others have taken that design and 3D printed it and started to manufacture it. Since we're closed out of the Sinclair lab, I don't have access to the lab to create the 3D printed parts, but we're actually, the designs are being manipulated for 3D printed face shields using screen protectors or overhead the film for overhead projectors. So the sheet protectors / there's plastic film that you use to write on for overhead projectors, and simply you could use it as a 3-hole punch scenario and lay it out for that. But yeah, there's the design, and so we created a Fusion design team and invited our colleagues to work on that project as part of that Fusion design team. So the team component can work pretty well. Oh, matter of fact, I do have M&Ms here, so we could measure M&Ms live on Wednesday if we needed to.
I got jelly beans.
Jelly beans would work is another thing, and so we can do we could share 3 or 4 different components, or you could do coins. Coins are a little bit more difficult too. So I'm good with either as we go forward here. Okay, so that's the team part. Also here on the left-hand side is where all your projects are listed. So inside your team, you can create folders. Inside your folders, you can put projects. So right now I've got a area for class instruction. I can create a folder called Caster. And so our drawings that we're going to create for the Caster will go into that folder, and so we'll be able to save them. The best part about Fusion is you never have to worry about where is my file? Did I save it to my flash drive? Oh, I forgot to email it to myself. Because every time you log into Fusion, your files are now there. Whether you logged in at Sinclair on one of our stations or logged in at home, your files are tied to your account. You've got online storage, which again costs money, but Autodesk gives it to students for free. So that's part of the cool part of being a student. And by the way, you get it for like 3 years for free as part of that. Okay, so I started a new
Nice.
project. Yeah. So I
Still
started
on
a
the-
new project. You're still on what?
It's just still showing the caster.
Oh, really? See, you got to let me know those things because I'll start moving around and forgetting to go to the right software tool. Yeah, I wish I could show both at once. Now, how could I do that? Could I bring in, hang on, let's see what happens here. Let's see if I could bring in my Caster image. Oh, that's pretty small. It's there, but it's small. Okay, so let me undo that. Insert. Wants me to put it in on a face. And canvas opacity is at 50%. Selectable. And scale. Sorry. So that's 3 times the original size. Display through. All right, so we'll throw this caster up here. If I have to, I'll delete this. So what I can do is I could actually create a new project, and we can just flip up and back between these two now that we're in Inventor here, so we can look at the right side view. So here's our caster project. I knew there was a way that we could make this work. So the caster project, as we talked about, has just some basic shapes and components. It's a pretty easy assembly. And so with that, we could then save inside that caster folder. Now, over on the left-hand side here, with creating that folder, I just picked new folder to create the folder. I could then save each of the drawings inside that folder as we go forward. Typically, though, you can either hit the X or you can hit this hide data panel. Either way, we'll get a full screen for you to be able to use. And so, again, simple, the data panel will bring up all your drawings that you're currently working on or have worked on. We can create new designs under here. They just added new electronics capability to this, being able to do electrical schematics and wiring diagrams and other components associated with it. So you begin with the design, and I'm actually going to create a separate new design here because I'll leave one for the problem, and then I'll create a new one for our actual design. So once we've created that new design, the first thing we're going to do, we'll create the top plate, because that's of course the easiest to do. And so with this top plate, it's a 3-inch square steel plate. So we'll come over here to our drawing environment, and like we've done with Inventor, we have to create a sketch. And so the first thing we do is create sketch, and we pick a surface to create that sketch on. Well, I'm actually going to pick the plane here on the bottom as the sketch plane, and I'll create a rectangle, and we'll get it to about 3 inches. I could actually make this exactly 3 inches by 3 inches if I use my wheel to zoom out to get it exactly 3 inches to 3 inches. But that's not a requirement, because once we create the object, we can then add the sketch dimensions. Again, just like Inventor, no differences. And so you can add your 2 dimensions. And it's a 3-inch by 3-inch size. Over on the right-hand side, they've got the different tools that you can turn on and off in terms of the sketch grid behind it, snapping to specific grid spacing, which I think is like in a 1/10 of an inch right now, showing the profiles and the different points. So you can control what's physically visible on your screen with this.
Tom, what's the unit you use? Because I'm in millimeter now.
Yeah, so if you need to switch units, okay, so if you pick millimeter or you're in the millimeter environment and you need to switch units, under document settings on the top, on the left-hand side on the top, it's got a little gear there. You can switch your units from millimeters to inches or inches to millimeters. It's a good point. And I probably should have done that initially, is to verify the unit of measurement. Way easier than Inventor, having to switch units of measurement, having to go under 2 different menu areas. But yeah, under document settings, you just set your units of measurement here on the left-hand side.
Make it to the inch?
Yeah, this particular drawing is in inches. So everything that we're working on is going to have inch measurements. So first thing that we're doing is the 3-inch square steel, and then the holes are a 1/2 inch by 1/2 inch, and they're 17/32 with that. Okay. So the thickness of the plate is 1/8 inch thick, okay, for the plate itself. So once we create the 3-inch by 3-inch, we can finish the sketch, and then
extrude.
Well, it is kind of like I just hit the home button. It's called extrude, but a lot of times you'll do push-pull, and I can grab the surface. I have to pick the surface, but then you've got the push-pull capability with the arrow. I can either push it down or I can pull it up, depending upon the direction that I would like it to go. And so I can also change the angle, which is also something unique and different that you can't do in Inventor, but I can change my extrusion angle. This is 1/8 of an inch, which is 0.125 of an inch. Too many decimal points. So this is 1/8 of an inch. So I just grabbed the arrow, moved it up a little bit, typed in 0.125, and chose OK.
0.125.
Yep. Okay. So the deal is that we have 4 holes that are 17/32 diameter, and they're each a 1/2 inch in on that plate. So if we look at the plate, and I can look at the top plate, what I can do is put a sketch. I don't know why my nose is so itchy today. Sorry. I keep scratching my nose, but my nose is itchy. We can put a sketch on the top plate and then put 4 points where those holes are going to be located. So we'll put a sketch on the top plate and we'll use the point tool. So we have to go using the arrow, the drop down arrow, and we'll use the point tool to locate 4 points. And you can see that it kind of snaps to different locations on the grid. And so we can pick 4 points on our drawing environment and then dimension them.
Section. How I
So-
get to the points? Like,
Well, we have to create a sketch.
okay, I did. I did a new sketch on the top of the plate.
Yeah,
Right.
0.125, and then we created our plate, and then I created a sketch on top of the plate.
Mhm.
Then on the drop down under create, there's the point command, and I picked the 4
Oh, yeah, I
points.
find it here.
And then I'll add the dimensions
Point.
to the points. So we'll go to the top line. How about that? It's exactly a 1/2 inch. From here to here, that's exactly a 1/2 inch. Here to here. Whoops. And so I'm dimensioning the points. And again, I'm dragging the dimensions off the edge of the part. This one's wrong. And so we
It's
dimension
It's
all,
half inch for the 4 of them, right?
yep, 1/2 inch off of each of the sides. And again, you can do this in Inventor. You know, again, nothing that we're doing here is any different than in Inventor. It's just a matter of where the tool is up on the top ribbon panel. That's the only difference. And once we have the 4 positions dimensioned, then we finish the sketch and do the hole command at 1730 seconds. In that hole command, we pick all 4 of the sketch locations and we drill the 4 holes. And so the process of creating this is no different than Inventor itself. So we finish the sketch, go to the hole command. The hole command, what we want to do is pick the 4 points, and the diameter of the hole is going to be 1730 seconds. So we actually just type in 17/32. Depth of the hole is just through all. And we've got our 4 holes.
How do you find the through all one on hole tab?
Oh,
Hole
up here
tab?
on extents, it says just go all.
Oh, yeah, distance. Yep.
Yeah, so
Find
yours
it.
would have distance, you switch it to all, and then
Mhm.
at the very bottom it's 1730 seconds. And boom, now we've got our plate with our 1730 second holes. Now it does have a fillet around the edges, okay? And it looks like the fillets are a 1/4 inch fillet. Those aren't marked. Okay. And so looking at this being a 1/2 inch, could be an 1/8 inch fillet around the edges. So if that's a 1/2 inch, we could try either a 1/4 or an 1/8 on the filleting. So a couple of things that aren't shown on this is where the vertical supports need to be placed. Well, the vertical supports need to be placed on the inside of the holes, but it has to be 3/4 of an inch wide for the plastic rollers. And so we have to think about, when we're designing these components, where that happens to be located, or how that is actually located. So let me flip back here. So we've got these. We could put the fillet, and again, fillet. We pick the edges to put the fillets on, and let's see here, 0.25. Yeah, 1/4 inch looks pretty good, actually. I only picked one, but when we look at that, the 1/4 inch fillet looks pretty darn good for that plate. So you can do the fillets by picking all the edges and then typing in 0.25. Well, 1/8 inch looks good too. I don't know. What do you think, group? 1/8 inch or 1/4 inch?
I think 1/8.
Because there's a 1/4, there's an 1/8. Yeah, I'm with you. Maybe an 1/8 inch is better. And so now I've got to go back and edit that fillet. Oh man, what am I going to do? So I got to edit this fillet. So here's the cool thing about, and again, nothing different than Inventor, but you can highlight the feature and then just say, I want to edit that feature. Because I put in one of them at a 1/4 inch, and I can change that now just by highlighting that feature, right mouse clicking and saying edit. So I don't have to go and find it in the list, or because it is in the list, but actually the list is not on the browser. The list is along the bottom. So everything that we do is saved as steps on the bottom here. That's the cool part about that, is that everything we do is saved as steps.
How much is the fillet was?
0.125.
0.125. Thank you.
All right, we're coming up on the 10 o'clock hour. So it's probably time that we take a short 5-minute break. And we'll be back at 10 o'clock.
I have a question, Tom. So the fillet is only on the corners, like on the edges?
Yeah, so we do the short little vertical edge is all we're filleting.
Okay. 0.125.
Yeah, and you can actually pick all 4 at once and do it as 0.125, but yes.
That's what I'm trying to do, but it didn't let me. I don't know why. So I have to do it one by one.
No. Let me delete them. So now when we do the fillet command, you can pick, if you take a look at my screen, I can pick all the corners at once. So I've picked all 4 corners now, all the short verticals, and then I can type in.
Yeah, like when you did that, like when I choose the fillet, it just pops up the screen for the fillet measurement, so I can't even pick the corners, you know. Okay, now it does work.
Yeah, it pops it up and it wants you to do that, but you just pick you don't have
corners.
to type it immediately. You just pick all the corners first, then type in the distance. And then all the corners are exactly the same, 0.125. And of course, it's always good. It will automatically save your work, but it's always good to hit the save command. When you hit the save command, you can then choose where it will actually get placed. So under class instruction, caster, under my caster folder that I created, and I can call this top plate. Not trop plate, but top plate. And so this will be called top plate.
Save it to
I created a
admin.
folder, but you can just save it on your listing. So you could actually, I have a folder called
I just
caster that I saved it in. But you can just, you can
Yeah.
actually move it later, by the way. You can actually drag and drop things in this folder and move it around to reorganize. All right, we're going to take a 5-minute break. We'll be back exactly at 10 o'clock, and we're going to give everybody a short break here, just like in class. And since we're not having to travel too far to do our components, we'll make it a 5-minute break. We'll come back and we'll work on the next component and lay out the center arms of this assembly. All right. I'll continue to share, but I'll stop my video and I'll mute myself. Uh-oh, there we go. I think that should be better. Okay. Let me see. Let me double check here to make sure everything is back. Yep. All right. All right, so we have that and we're all set. All right, are we back live again? So we have to create this arm that'll hold the wheel in itself. And so, straight segment for connecting support. And then we've got a 1/4 inch circles for construction purposes. Okay, so it's a 1/4 inch down, 1/4 inch over. Okay. And so what we're going to need to do is create some work planes on our object to locate this support. And there's a couple of ways that I'm thinking about doing that. I'm thinking about creating this as a solid object under the plate and then extruding out the middle, cutting the middle out so it becomes one piece as opposed to 3 pieces. We could start a brand new component as opposed to attaching it. And so let's talk a little bit about, are we all back? I don't want to go too far.
Yeah, I'm here.
Okay.
So we just create a new design, right? Yeah. After we save the plate.
Yeah, so what we're thinking, there's a couple of ways that we can do this. For example, if we wanted to create this as an assembly where there's 3 parts plus the wheel, what we can do is begin a new design for the arm, the support arm. And to do that, what we'd want to do is develop a new body. Because right now we've got body 1, which is actually the top plate. So what I can do, screen should still be sharing. I can use the down arrow here. I can slow click, and this is why it's so important to change the name of objects. When you change the name of the objects, there we go. I can hear myself in my headset now, so it makes it easier. It makes it easier for us to see exactly what each of these bodies are. And for it to be an assembly, the body has to be turned into a component. It's not hard. You just right mouse click on it and you say create a component. And then that's now a separate object. So if you think about it this way, bodies, if you create a body, it's one object. If you create components, it's multiple objects. And so we're going to create a component. We'll keep this as the top, and then we'll create the side. So notice that it changed the logo on it. It's now an object. It's a box. It's no longer a body. So we're going to create a new body based on the side. We're going to create a sketch on the side of our object and create that shape of this wheel component. And that's going to be a separate object that we're going to create as a separate component. All right. So to do that, we'll begin the sketch. And we can pick the object side, or I can pick just the vertical. both are exactly the same, makes no difference. So now
I
we've
gotta
got,
go back to I gotta go back to the plate because I saved it and I start a new sketch from the beginning.
no, you don't have to start it from the new beginning. What you have to do is take that body and create it as a component. Just right mouse click on the body and change it into a component.
Yeah, I'm trying to go back to my plates. Do you know where I can find it here in the Fusion? Or just gotta open it from the beginning?
What do you mean? Where to find it? You
Yeah,
close the plate?
yeah, I did.
Oh, so what you have to do is hit the show data panel.
Where? Oh,
That's
okay.
the box, the
Uh-huh.
data panel. And then under the data panel, you should be able to find your top plate.
Oh yeah, here we go. You picked the side, right, for the new sketch?
Yeah, I just picked the vertical XY plane. I just picked the vertical XY plane for that sketch, yeah. And so we're going to create another component, and that's the difference. You know, that's a huge difference between Inventor and Fusion, is taking bodies and changing them into components for assemblies. And that's the difference of that we don't have a separate assembly area versus a design area. When you design it, it's all under the same area. You're just changing the object to a new item. All right, so
Mhm.
when we're looking at this, it looks like we have to draw a couple of 1/4-inch circles here, and locating it from the center line, it's going to be 1 inch off the center to this location here. We don't have a distance, a vertical distance, however. We know that the wheel is 2.5 inches, and we're going to need a space under the wheel. So my guess, and again, it's a radius of 2 inches, but we don't have a vertical distance. So we're going to have to determine what the proper vertical distance is for a 2.5 inch diameter roller. So this looks like about a 1/2 inch space. So I'd say 3 inches down would be my guess. All right, so we're going to create from the center line, we're going to create some construction geometry here. 3/4 inch, 0.875 back. Okay. So from the center line, now we're going to have to draw a line and change it to a construction line. So the first thing I'm going to do is draw a line. Pick it, right mouse click, and I'm going to change this to a construction line. So the software itself utilizes construction geometry. It doesn't differentiate between center lines and construction lines, as far as I can tell, with my experience. So we can either do normal construction, or we can do, you flip between a normal line or a construction line. And we can provide a, we're going to have to project the geometry. Oh no, projection of geometry. So just like Inventor, there is the ability to project geometry. So remember, we put fillets on the edges here, so they're no longer square. And so we have to, under create, there is project, and we want to project that edge. So we can project this line and this line. So just like Inventor, we can project geometry, because since we have the fillets, we have to project these straight edges to get the distances correct. And then I'm able to dimension from the projected line And at a 1.5, we know that that construction line is in the center. Does that make sense?
How do you choose the center line?
So what you do is you just draw a standard line, just draw a regular line,
Mm-hmm.
right mouse click on that line, and then you'll have the option to create it as a construction line. So there's it's a switch. It's either a normal line or it's a construction line.
Yeah. Okay, fine. Thank you.
And so then you've got these two. From there, now that we have this construction line and we projected this edge, go ahead.
You did the dimension from the center line to the corner?
Well, I did the
that.
center line to the projection. So under create, you can go to project and then project that edge. Just project. You have to zoom up on it and you have to project the edge.
Both edges or only the edge on the right?
Yeah, it's going to try to do a square, but you got to kind of move it around. You'll get just that edge.
Mm-hmm.
And then you can dimension from that edge to the center line, and then you're fine. One of the cool things is that it does have the offset capability. So let me look at the dimension here. So we're going to offset 0.75. So we're going to offset this construction line. When you pick it, you're then able to grab it and then move it. So this is going to be negative 0.75. And then we can pick that line again and make it a construction line. And we can do the same thing to the other direction. So we pick drag and 0.875. And then make that a construction line. So again, what I'm doing is I'm following, here's the center, did the 7.5 to the right, did the 8.75 to the left to get the locations for the top. Then we'll do another one at 1 inch down to get the bottom here in just a minute. All right. So at this point, we've got the two locations here. This happens to be a distance that is a 1/4 inch down from, it looks like another plate. And again, that plate isn't dimensioned. So we have to make an inference of what that plate thickness is. If this is an 1/8, then that's a 1/16 of an inch. But for our design, we're just going to run this exactly up against the 1/8 inch plate. So we'll just offset this a 1/4 inch down for construction purposes. So what we're going to do is take this line, offset it down, and then we'll create that as a construction line. So we'll do offset. I guess I can't offset, so I'm going to have to pick this and then pick offset. Nope, I'm going to have to draw a line. So I'm going to have to draw a line below, change it into a construction line, and then dimension this. And that's going to be 0.25. And so drawing that line, making it a 1/4 inch, this allows us to draw construction circles on the two locations here. Oh, hang on. I might have messed up here. That's a diameter 1/4 inch. So that, oh yeah. So if that's a diameter to a 1/4 inch for that circle, then what should this offset be?
Yeah.
Half of that. So it should be 0.125. So again, working with that. And then we can create our construction circle. So far, so good. We got our construction circle set up. We got the 0.75 to 0.875 construction circles located. We'll locate the bottom circle location here next, and then we'll start drawing the geometry in to create this arm. All right, so our last offsets that we have to do is we're going to take the center, offset it 1 inch over. So we'll use the offset tool again. Pick the center, offset it 1 inch to the left-hand side. Make that a construction line. And then I'm going to need to draw another line. This one doesn't have to be as long. Horizontally, again, create a construction line. And that line is going to be dimensioned. Let me flip this over for a second. Oh yeah, we said that was going to be 3 inches from the bottom. So from here to here, dimension from the line to there, that was going to be 3.0. Uh-oh. So we got a problem, don't we? I just dimensioned this. The construction line went off the overall distance, but what I can do is just drag this line farther down. Notice that it doesn't change any of the vertical dimensions. It just changes the horizontal. Or instead of dragging it down, I can use the extend command. So under modify extend, I can pick just this line and extend it to the intersection. Both will work. Both will work. And so now the question that I have for the group is this line, this particular construction line, notice that it's a different color than the other ones. Why is that? See, all the other construction lines are black. This one is kind of like a brown orange color. Why is that the case?
Because you did offset to it.
But I
No,
offset all the
ours
I offset all the
Yeah.
other vertical lines too. But what's different about this one? Any thoughts? Everybody's looking at it going, I'm not sure. Take a guess. It's just like Sesame Street. One of these objects is not like the other. Which one is it? Do you know?
I don't know. Is there just some different constraint on it, or
Didn't have a dimension on it. Notice that these both have dimensions. When I place the dimension on it, it changes color. So it was not constrained. So tip, objects that are a different color in Fusion are not constrained. So down here, I need to draw a circle. Down at the very bottom, we need to draw a circle. That circle, I have to flip back, sorry, has a diameter of radius of 0.375. Okay, so we then can put a dimension on it. So it'd be 0.375 times 2, or 0.75 would be the diameter of that circle. Now these construction, okay, if you take a look at it, we've got a tangent arc that is now going to be used to create the arm. So now developing a tangent arc, so if I go arc, tangent, let's see if this will work. So I'm going to create a tangent arc from here. Let's see here. How does this work? Specify start point. Oh, it wants points. To specify those points. So maybe it's better to draw a circle and then create it as a tangent. So the center point, we don't know exactly where the center point is. So I'm testing this, by the way. I've not done this before. So again, this is live. So if I do this and draw a circle, and then I use the tangent tool and say I want to make this tangent to that circle and this tangent to this circle. Oops, not big enough. See what happened? It made a tangent here, but it made a tangent to the top instead. So now I got to undo the circle and make it a little bit bigger. Now I can use the tangent tool and say I want to make the circle tangent to that arc. Not exactly what I was shooting for. All right, let's undo. Let's try this first. Tangent from here to here and here to here. Winner, winner, chicken dinner. So we created a tangent to tangent, but I had to draw the circle big enough to make that work. Now the question is there a radius on that arc? It is 3.0. So now that I've got a tangent to the two objects, I can then add the dimension. And so a 3-inch radius is a 6-inch diameter. And now I can trim it. Okay, that's trimmed there. This is still getting trimmed down. So now that's trimmed. And there we go. Okay, so that's about where it needs to go. Now it did say that it wanted a straight line here, but we'll play with that. All right, so did you see how that will, do you want me to recreate that again? Nobody is saying a word. So I guess not.
No, I don't. I think I got that.
Same thing will happen here, is that we're going to create another arc, same concept with that. And the key is that it's not about creating the arc, it's about creating the circle. And then using the tangent tool to position this. And I specifically picked specific locations to make them tangent. Okay, so this happens to be a 2-inch diameter. Or 2-inch radius, 4-inch diameter. So that looks a little bit weird. Why is that the case? .75. Then this is too long. So this has got to be 2.5. So it's one. Bet you that's only 2 inches and not 3 inches. So I set this at 3 inches. Let's reset this at 2 inches. And trim this up. Oh yeah. See the difference? And did you notice that I could change that vertical dimension on the fly to reposition these?
Yeah.
To make that able to, let's see if we extend this. There we go. To make that, because it didn't look right. And if it doesn't look right, it's probably not right. This one looks much more realistic. Since we don't know exactly what the vertical dimension is, we do know that it's a 2.5-inch wheel, so that's 1.25 inches. And I added another 1/2 inch. So it could even be 1 3/4. Since we know that that's a quarter, this is a 1/4 inch. That's another at least 1/4 inch. So yeah, it's either 2 inches or 3 inches down. Let's see. What if we did 1 3/4? 1.75. That looks even better. You know, when you look at this, I bet you it's 175. So we've got this with the arcs. And again, creating the arcs, it's not about creating the arc, it's creating the circle. Now that we have that completed, we need to finish drawing the straight lines up and across to create the connection points. So we'll draw a line straight up. Draw a line straight up. And then draw a line straight across to finish the object shape. Now that we've got the object shape, I can trim this arc, nibbling away at it. And so now we can extrude this piece. So we can finish the sketch, extrude just this piece, 0.125. Now, here's the thing. We extruded it. We'll probably need to go negative 0.125. Now, we created this as an object, or we can do it as a positive 0.125. That's fine. Because we're going to create this as a component, and then we're going to copy the component and position them. So as you can tell, what we're doing here is we're now just creating that arm, and we'll say it's a new body. Okay, now I could automatically make it a new component with the extrusion. So I could actually go directly from the object to a component. However, I still need to put a hole in for the axle, which we haven't done yet. And so I'm going to create it as a new body so I can put the hole in for the axle. And again, I can use the hole command. Right now it is not in the right position. The reference I want to pick is the arc. Sketch from single point. Let me control that. I want to pick this face. Concentric is the key, is that was what I'm looking for. So this reference I want to pick is there. So the question is, why is it not? Why is it not using the concentric? Whoops. 0.25. Select on the reference. So it's not allowing me to do that. So reference 2. Reference 1. Yeah, so I'm going to have to create a center point here to locate that hole. Yeah, it says it wants to use edges, so I'm going to have to create a sketch, put a point on it. The point will be, that's the center of this arc that just highlighted. Finish the sketch, create the hole based on the point, 0.25. That was a lot of work to get that hole, but you have to create the sketch to create the point to locate it in that concentric location. All right, now that this is the body, we can right mouse click, and this is the, we'll call it arm. We'll create it as a component. So we've got the top plate and the arm. And the next thing is that we need to do is position it. So you can see that we can position this arm now anywhere. We haven't constrained it at all. We have not constrained that arm. So let's go ahead and copy this, because we need to create a second arm. So we can choose copy and paste. Some components have been moved. We're going to capture the position, and I can then paste it. And so now we've got 2 of the arms associated with it. So the idea of creating the geometry is easy. The constraining components is a little bit more difficult, not substantially, but a little bit. And it's a difference in philosophy. So with this, we want to create just one constraint. That one constraint is going to attach the object to the top plate and position it all at the same time. So unlike Inventor, where we create a make constraint on the top to the bottom of the top plate, and then we create a flush constraint and offset it in, this will do both. This constraint, this joint is what it's called, will be able to mate to the top plate and create that flush distance automatically as part of that positioning. So before we do that, we need to know how far in we want to create that distance. So we know that we want to bring this in, let's see here, 17/32, so that's about a 1/2 inch diameter, a little bit bigger than a 1/2 inch diameter. And then those are a 1/2 inch in. So if we brought this in 1 inch, 1 inch, that would be, yeah. So we're going to bring it in 1 inch from each edge. So from this outer edge of the plate, we're going to bring it in 1 inch. And we can always adjust it. That's the good part. So we're going to go ahead and assemble a joint. So the joint that we're going to assemble, and again, here's what's different, is that when I'm picking things, notice that I've got a variety of different positions to pick. I can pick the edge on this top surface. I can pick a corner of the top surface. So what you're doing is you're selecting a reference location that you want to use to position the object. So if I pick the middle of this arm on this top surface, we know that that is going to be offset 1.5 inches to center it. Does that make sense? Yes or no?
Yes.
Because we know that the square plate is 3 inches, so the middle of this arm needs to be centered in that plate. It's 1.5 inches. So knowing that location, I can pick that particular object. Now we have to pick a spot on the bottom of the plate for it to be positioned to. So if we know that it gets positioned in the center, we know that the distance off the center is going to be a 1/2 inch to each side. So I can pick that same position and then adjust the alignment 1/2 inch over. So you can see how you can do this with just one constraint. I didn't have to do a flush and then an offset from the flush. I picked two locations that were known pieces of information and then provide that distance that we need. So I can do it to the same, I can do the same thing on the other one. So you can see how it's offset a little bit. So we're going to assemble the joint from the top center. I need to go to the bottom here and find that position. There's the center again. And slide it over a -1/2 inch. So two constraints applied this particular position. That's the hard part about Fusion, is getting your head around how to constrain things. And once you get a little bit of experience, and this would be a really good project to do it with, it actually makes sense because you're picking known locations and you're offsetting from those known locations the position of the objects. At this point, we can create a new component. We can create a new body, we can create the wheel and the pin, you know, and finish off this particular project. But I wanted to stop and see if there were any questions that anyone may have.
This doesn't really regard the caster, but as of right now, it's just the diving board and the ArborPress video, everything that we need to turn in.
So diving board, ArborPress video, and I'd start working on the micrometer and inch readings too.
Okay.
Those won't take long, or shouldn't take too long. But the key is that you do want to start practicing with the Fusion software. And to start to become familiar with it. But yeah, the constraining on this actually work, again, work from a known location and then constrain off from that known location. With this project, I'll probably create an actual video that I'll post to my YouTube channel as an open YouTube video on this particular project. You'll get to see the whole thing and the errors, the learning errors that we had on our private
Nice.
video. Yeah.
That will help a lot.
So yeah, that's the thing, is I've been recording this whole session, so you can replay the whole session if you want. But I'll probably create a separate video with just this, because this actually is a really easy, simple project to use.
So if I want to rewatch this, where I can find it?
So I have to process it and upload it to YouTube, and it's going to be a private link.
Oh, okay.
And I've been emailing the private links in eLearn.
Gotcha.
So like last week, I emailed the private links. And so the private link is what gets you the access, because it's not going to be a public video for this Fusion component and body. But yeah, creating the rest of this is actually pretty easy. You create the wheel, put the hole in on the wheel, position the wheel, and create an axle or a shaft for it, and press the shaft in, and you're all set. And the key thing is that just think about, when you're doing the constraining, what known information do I have and what data points is it allowing me to select to accomplish that positioning. So, but that's it. That's all I've got for you today on Fusion and assemblies. Now, to create a drawing from this, let's go ahead and save this. So if we hit save, notice that when I hit the save button now, it comes up with a different component, and it says, hey, user saved, and I can give it a name, but I can also say that there was a milestone. And so the milestone.
What is the milestone?
So like for example, I type in assemble plate and arm, and if I make this a milestone, what happens is that this becomes a new selectable object. So let's see here. If I choose OK, and then if I go back to my show data panel, I've got version 1, version 2. You can see what it does is it saves this milestone assembly version 2. And 6 seconds ago, it did an updated intermediate save. That's the nice thing about Fusion, is that it does automatic saves behind the scenes that you don't even know about, and you can always go back and accomplish that. The last thing I wanted to show you was it's really simple to do drawings, because I could just go to the drawing and choose, I want to create a drawing from the design, and I pick the object that I want to draw. So if I want to create a new drawing, if I want to create the whole assembly is selected. The templates from scratch. And if I don't want to do the full assembly, notice that there's a checkbox over on the right-hand side here that says full assembly. No, I can pick just the object to do a drawing with. So I can do a full assembly drawing, or I can uncheck the box and do individual design drawings of components. That makes it really nice. And so you can actually build a drawing package just like we did in Inventor. doing it the same way inside Fusion. This is what makes this nicer than SolidWorks. SolidWorks is a little bit clunky on the drawing side and doing dimensions in the drawing aspect. This is as smooth as Inventor. They brought the really nice features of Inventor and the ability to create drawings into Fusion with that. So again, you can choose your sheet size up front. You're not having to go back and edit things or create a new template. If you do create a template, you can go ahead and browse it if you have saved a custom template. But I wanted to show you that creating a drawing, we'll just pick this arm and choose OK. And it creates the drawing for us. It's working on the drawing sheet. So there's our drawing sheet. There's my front view that I just created. I can then project the views, again, just like Inventor. I don't have to have more than one view, but I can create the isometric. If I want to shade it, I right mouse click, edit the view. Wow, does this look Inventor-like? Absolutely.
How do you put I keep deleting the browser on accident. It shows all the different things that you're doing with each sketch and all that. How do I go back in?
You keep deleting the browser.
Yeah,
So
moving it.
Don't touch the browser.
I didn't do it on purpose.
Oh man. So to bring the browser back up, good question. Let me finish this for a second, and that way I can get out of this. So I'm going to make this solid and close. So I can, so bottom line is I can create this as a solid object. All right, so you keep deleting the browser. So the browser, let's see here. If I hit this X, I don't want to delete mine. Then I'll have to find it.
Well, how do you pull it up on Inventor?
So it's under the View tab on Inventor, but here we don't have the View tab, so it's got to be a Settings. Let's see here.
Who told you to do it, Joshua? Why you keep playing with it, man?
Where's it? I'm trying to find it on Inventor too. I can't find it.
Well, on Inventor, it's under View, User. Again, I'm going from my memory here. I can let me bring up. I don't even have an Inventor drawing open today. Browser. Let's see here. Inside here, settings. Let me think. Browser. So you're looking for the browser inside Inventor. It's under View, User Interface, and it's called Model, I think. Is the
Yep.
inside Inventor. Oh, cool. They've added a new additive manufacturing, metal additive manufacturing components to the capability. All right, so let's see here. I'm just checking to see.
Well, I know I'm going to end up doing it, so.
Operational warnings. Setups, create folders, calculate, suppress an operation. I don't know if you can delete the browser here. You can minimize it. Well, let's see here. All right, let's see. Worst case scenario, I hit this little minus button. Nope, doesn't go away.
That's good. Maybe that's a new feature they fixed.
Just for you.
I'm probably not the only one.
It's a just for Josh feature operation. So anyways, the views and so forth work the same. You can add dimensions just like you did before. All that works exactly the same as what we did previously, like in Inventor. I mean, it's just that simple overall. All right, there we have it. It's totally wrapped up. and packaged. So homework wise, I sent you a email this morning, an eLearn about homework. What you need to get done. If you haven't done that already, I'm going to grade probably this afternoon. So hopefully your arbor presses are loaded in there so I can grade them. Diving boards, you want to work on those. And the inch micrometer, you want to work on that. And then start thinking about what you plan on dispensing. Wednesday, if you want, we can measure M&Ms because I've got peanut M&Ms here. I don't think I've got any regular M&Ms. Josh says he has jelly beans. I might be able to find some other candy. There you go. See? Oh, those would be fun to the Mr. Good bars and little Hershey bars. Those are fun to dispense.
Yep.
But the idea is that we can measure those. I can grab the micrometer and we can do some measurements on components. And if you want to do coins, you can do. You don't have to sort the coins. You just have to dispense them. So the idea is how would you dispense coins? And you're not going to be dispensing just one M&M. You'll probably be dispensing a group of M&Ms. However, like on Josh's little Hershey bars, those you'd want to dispense one at a time. So that might be a different mechanism. And so when you think about the candy dispenser, it's all about creating mechanisms. So you have to use a mechanical process to dispense it. And a drawer is not a mechanical process. It is, but it doesn't qualify. I've had students go, oh, well, I'll just create the drawer. And you just pull the drawer out. And as you pull the drawer out, it's going to have candy in it. And that doesn't work. You have to have a hopper and some type of mechanical mechanism to dispense the candy. So just to kind of give you a preview of what's coming up and what to expect as we go forward here. Any final parting questions?
Nope.
If not, I will be online again tomorrow night from 7 to 8 o'clock. Links I sent last week for the Tuesday evening, those are a different connection link than our regular class. And if you don't join us tomorrow night, that's okay. It's totally optional. But we'll be back together on Wednesday morning, bright and early at 8:30. It is nice to keep a schedule though during these weird days, especially if you happen to be off from work currently. It's important to keep a schedule. Getting up at a fairly regular time and providing a list of tasks that you want to accomplish. It sounds like we're going to be managing this for a longer period than just through April 6th is the way that it's starting to look like. So to keep your sanity and your process, the idea is to maintain a schedule, and you'll do much better that way. And so having your 8:30 a.m. class is definitely helping you keep that schedule and that process. So have a great afternoon. Looks like a really pretty day outside.
Yeah, you too.
When I look over my shoulder and look outside, it looks nice.
Oh, it's windy.
Yeah. Is it windy?
Yeah.
A little bit of wind. Yeah, it's a little windy, but it is pretty. It's nice when it's sunny. That's for sure.
It is.
So, yeah, we'll see you on Wednesday for sure. And if you have any questions, I'll be online tomorrow night to answer questions. Definitely download Fusion. The top plate drawing, I sent that to everybody so you can actually practice with what we just did. And I will upload this presentation as a private upload, and I'll email it to you.
Thank you, Tom.
All right. Have a great day.
You do the same.
We will. I'm going to stop my share and end my meeting.